Yesterday we studied about the frictional losses in pipe. So we are having a pipe. Through which there is a flow, and we are considering two sections. Here the pressure is P1. Here the pressure is P2, and here the pressure force is P1 into A. Here the force is P2 into A, and F1 is the frictional force, which is in the opposite direction. Okay. In order to derive Darcy-Weisbach equation, first of all, we have to apply Bernoulli's equation. So, at section 1, it is P1 by rho g plus V1 square by 2g plus Z1. And at section 2, P2 by rho g plus V2 square by 2g plus Z2. And as the flow is steady, this V1 is equal to V2. Therefore, V1 square by 2g and V2 square by 2g times cancel. And also, this Z1 is equal to Z2. That is, the potential at is same. Therefore, the remaining term is P1 by rho g is equal to P2 by rho g. But we already said that there is a frictional loss. Therefore, P1 by rho g is equal to P2 by rho g plus HF, where HF is the loss of head due to friction. Therefore, HF is equal to P1 by rho g minus P2 by rho g. This is one equation. And from this equation, you can see that P1 minus P2 is equal to rho g HF. Okay, P1 minus P2 is equal to rho g HF. And similarly, while we are equating the forces, so first of all, we applied Bernoulli's equation at the 2 section, and there we found a relation for P1 minus P2 is equal to rho g HF. Next, we have to equate the forces. That is P1A minus P2A minus F1 is equal to 0. And in that, F1 is equal to P1A minus P2A. That is, P1A minus P2A is equal to P1A minus P2A is equal to F1. And for that F1, we already having another expression. That is, F1 is proportional to the frictional resistance per unit wetted area into the wetted area into V raised to n. Here it is V square. Therefore, this F1 is replaced by F dash into pi d into L into V square. So, therefore, from this, we are having the relation P1 minus P2 is equal to F dash into pi d L V square divided by A. Okay. So, already from the Bernoulli's equation, while we are equating, there also we found a relation P1 minus P2 is equal to rho g HF. Okay. Here we found a relation based on the forces P1 minus P2 is equal to F dash into pi d L V square by A. Therefore, the right hand side RHS of these two equations can be equated. That is why rho g HF is equal to F dash pi d L V square by A. Okay. For that A, we are substituting pi d square by 4. Then it will get F dash pi d L V square divided by this rho g into pi d square and that into 4. Okay. Then after that, this F dash by rho is replaced by another term which is F by 2, where F is known as coefficient of friction. On substituting F dash by rho is equal to F by 2, the above expression will become F by 2 into 1 by G to 4 L V square by D. That is HF is equal to 4FL V square by 2GD. And this is the loss due to friction. And this equation is known as Darcy-Weisbach equation. I think it is clear to you. Next, we have to study the loss of energy in pipes. So when fluid flows through pipes, it experiences some resistance. Due to the resistance of some of energy of the fluid will lose. This energy loss is classified as, that is, the energy losses are classified as major energy losses as well as minor energy losses. And the major energy losses can be found out by two expressions. They are Darcy-Weisbach equation, and the second one is CHEZY'S formula. And the second one, that is the minor energy losses may be due to the sudden expansion of pipe, sudden contraction in the pipe, bend in the pipe fitting, and an obstruction in pipe. So these are normally you can see in any pipe connections. So next, our attempt is to find an expression for CHEZY'S formula. The loss of energy or head due to friction from the Darcy-Weisbach equation, HF is equal to 4FL V square by 2GD. And where F is the coefficient of friction, which is a function of Reynolds number, and which is equal to 16 by RE. This is for the Reynolds number less than 2000. The coefficient of friction is equal to 0.79 divided by RE raised to 4. Then the Reynolds number varies from 4000 to 10 raised to 6. Okay. There is a correction. It is 0.79 divided by RE raised to 1 by 4. Okay. We are having the Darcy-Weisbach equation, that is head loss due to friction is equal to F dash by rho g into pi d L V square by A. And while we are deriving the Darcy-Weisbach equation, this F dash by rho is replaced with the F by 2, where F is the coefficient of friction. And this expression is just before that. That is why HF is equal to F dash by rho g into pi d L V square by A. F by rho g into L divided by hydraulic mean depth into V square. Then we can see that the hydraulic mean depth is equal to area of pipe divided by wetted perimeter. That is F dash by rho g, and this time that is perimeter by A into L into V square. In this expression, this pi d is the perimeter. Okay, and that will be modified as F dash by rho g into perimeter by A into L into V square. That is F dash by rho g, and this term is hydraulic mean depth. That is 1 by M into L into V square. F dash by rho g into 1 by M into L into V square. Okay. And from that expression, you have to find out the another expression for V square. Then V square is equal to HF by L into rho g by F dash into M. And in this, then V is equal to root of that rho g by F dash. There is an rho g by F dash into HF by L into M. This manipulation is for some adjustment for the expression. So that this root of, so that this HF by L will be indicated as I. That I is loss of head per unit length of pipe. That I is the, that is HF by L is HF, you know already, the frictional loss of head due to friction. That per length is indicated as I. That is I indicate loss of head per unit length of pipe. Okay. So this HF by L will be I. Okay. So M into I. Then this will be, here density is a constant, G is a constant, this also a constant, therefore this is indicated by another constant. Okay, therefore that expression will become, that is root of rho g by F dash is equal to constant. Therefore constant is termed as CHEZY'S constant. Therefore the expression for the velocity is equal to V is equal to C into root Mi, and this is known as CHEZY'S formula. That the value for M, the value of M for pipe is always D by 4. And so this CHEZY'S formula will give the expression for velocity. And this CHEZY'S formula as well as Darcy-Weisbach equation is mainly used to find out the frictional losses in pipe.